Our penultimate presentation today is the winner of the display category. This is in Taiwan. It's Memutar. No idea what that means, but the Architect's Laboratory for Explorative Architecture and Design. Welcome.
Good afternoon, everybody. My name is Christoph Krolle from the Laboratory for Explorative Architecture and Design, and I'm here with Garvin Goupil from Augmented Architecture to present to you the David amongst the Goliaths today, Memutar, a small bamboo structure that was prefabricated in Bali and reassembled in Taiwan using augmented reality technology. And this project is meant to display as a proof of concept that the integration of technology, latest technologies in vernacular craftsmanship, open up the design solution space for sustainable construction, while at the same time allowing local craft ecologies access to a global market. This project is built in Taiwan on a tiny site that was given to us at a university in the city of Hsinchu, next to a little lake there. And it was a commission that we were given by the Taiwan Bamboo Society as part of the World Bamboo Congress, which is a world-leading congress on bamboo architecture. And the brief was to showcase what the future of bamboo architecture could be through the form of a small installation and display that to the conference itself, but also to the university and the city of Hsinchu for years to come. So we took this on as a challenge to see how we could tackle several number of the Sustainable Development Goals, how we could use technology to allow for industry innovation, how we can use that to promote sustainable construction on land, to tackle the climate challenges that we face, how we could help through that reduce inequalities on a global manufacturing scale. Now, we all know that the construction industry is in trouble. We are responsible for far too big a chunk of the CO2 emissions that we have. And that comes largely because of the materials that we're working with. Concrete and cement-based or ceramic or steel materials account for a very substantial percentage of the CO2 contributions that we have. And you will notice that in this graph, bamboo is not even present. And the reason for that is that bamboo actually has a carbon negative content. The more bamboo you use, the more CO2 you actually take away from the environment. And the reason for that is because bamboo is an absolutely magical plant. It's a gift from nature that allows us to work in a very different way in architecture. Some of the bamboo species, and there's over 200 that we can use in construction, they grow over 1 meter per day, which means that by the time, if you have lunch next to it, by the time your lunch is finished, it's this much taller, which means you can actually see them grow, making them far more sustainable than any type of wood that you could find in the construction industry. And the geometry of the bamboo columns, being these pipes reinforced by diaphragms, also makes them immediately suitable for integration into architecture construction. On top of that, it's actually available in the parts of the world that are most rapidly urbanizing right now. So finding ways to integrate it a little bit more will help us at least tackle the problem. But there's a challenge that comes with it, and that has to do with craftsmanship. Currently, the hotspots for bamboo architecture are centered on a few locations like Colombia or Thailand or Bali, where amazing craftsmanship is available because it has been a vernacular construction material for centuries. And yet there it slowly starts to disappear as well because of the lack of integration of bamboo into modern construction, because the material is often perceived as a poor man's construction material. Now, in these hotspots, if you've been following the news in the past 10 years, you'll see that a lot of innovation is taking place. Amazing spearheading maverick architects are pushing the boundaries of what's possible with bamboo. But outside of it, it's really challenging because of the lack of access to craft. 8 years ago, we were on stage here as well when we presented how in Hong Kong, which is where we're based, and where bamboo is used in the scaffolding of all the hundreds and thousands of towers that you see there. And we demonstrated that through the integration of computational design and latest parametric design tools and physics simulation engines, we can really expand the boundary of what's possible with bamboo. But since then, in the past 8 years, as we've been trying to push this into environments where there's a greater need for this than Hong Kong, we faced the challenge of craftsmanship. So what we try to do with this pavilion is to demonstrate how we can make sustainable bamboo architecture more accessible and how we can overcome these restrictive local craftsmanship concentrations. And we did this through the use of augmented reality technology. You've probably all seen these headsets. Maybe you've had one on your head where you're able to project holograms in your field of vision, allowing to guide the construction. So AR technology is moving ahead rapidly with these latest technologies, but not just through these rather expensive headsets. Even through your mobile phone applications nowadays, AR is in principle available anywhere you go. In the slums or in the favelas, people will still have smartphones nowadays in their pockets that we can use to access that technology wherever you go. Now, this technology combined with global shipping infrastructure that allows us to move things at a very low cost, even a low carbon cost internationally, pushed us to a collaboration where my office, together with Garvin's and a bamboo manufacturing company in Bali, Bamboo Pure, and then two universities, NYCU in Taiwan and Hong Kong U, where we're also based at, to push for Memutar. Now, the project starts, of course, with sustainable bamboo growth, harvested nearby in Indonesia. Then the bamboo is treated, making it a permanent construction material that's not susceptible to biotic attack. The material is processed, it's cut to the correct lengths, split into the lengths and the geometries that we need, and it's glue laminated to produce some of the ring beams that we need for the final pavilion geometry, which is a simple hyperbolic paraboloid made from straight bamboo columns that are kept in place with splits that interconnect them, create a doubly curved shell structure. It's a rather small installation, a bit over 12 meters by 5.7 and roughly 6 meters in height. And as you can tell, it's kind of a structural piece of gymnastics as this super hyper lightweight shell is tilted on its axis to create this interior space that contrasts with the outside of it. So it's made from beton straight columns, asper columns, and then splits connecting it. The challenge was to produce details that would be able to be manufactured by the traditional craftsman and then reassembled by a carpenter who never worked with bamboo before.
So we were then flying to Bali in Indonesia, where augmented reality technology played a fundamental role in the realization and also future vision of this project. Augmented reality offers the potential to rapidly transform the way of how we communicate building instructions in a much more immersive and intuitive way by overlaying the digital design directly on the construction site in scale 1:1. Now, this is extremely helpful for the local construction workers who cannot read two-dimensional drawings. But now they are wearing these holographic headsets, which allows them to combine their expertise in bamboo architecture together with this visual overlay of a fairly complex design intent, which would usually expand their common construction solution space. So we were then shipping this pavilion to Taiwan. As you can see, there's still some space in this container for up to 4 of these designs, where the main idea is that this pavilion gets accompanied by a custom AR application that would allow for a simplified reassembly of this project by local workers without any bamboo expertise. Now, this process turns the construction into a simplified three-dimensional puzzle where every digital component now gets to be matched with its physical counterpart. This is extremely useful, especially for non-standard geometries like the ring beam that you can see here with its own unique orientation and location in space that would have been extremely challenging to be positioned without the use of this technology. But now this is accelerating the process of assembly and also allows for rapid error detection.
So as an installation on site, it's a publicly accessible pavilion that has since then been used for all kinds of spontaneous events like yoga classes or just as a resting spot. But the architectural design behind it was intended to create a very elegant white shape that would contrast with the surroundings. And then as people would go inside of it, suddenly they would be confronted with a more dramatic interior perspective where you would see the bamboo twisting, trying to trigger questions in the user on how on earth it was possible to actually control the construction of this.
So we were also developing a custom AR application that is accompanying this exhibition, which allows visitors to visualize the construction sequence of this project and also allows future clients to visualize different programs of this pavilion and also allows them to visualize and place this design on their own local properties.
So the idea is that this pavilion is not specifically designed for Taiwan, but actually becomes a product that can now be shared globally and become buildable easily at relatively low cost in any place or environment where you would want to have it, say a bamboo forest or a beach or a nice music backdrop like this one. But so the main message that the project is trying to portray and display as part of this conference is that technology can offer local craftsmanship, which is in need of being given a greater market, an opportunity to tackle a global reach, a global scene. And that's our presentation. Thank you.
Could you explain something about the engineering input? And I think I heard you mention 200 types of bamboo. Or do you mean 2 to 4 types of bamboo for structures?
There are 1,600 bamboo species in the world, of which 200 can be used in construction, because they're giant timber species with the high strength values that we need. And different parts of the world have different bamboo species locally available. We used the ones that were most suitable for this, coming from Indonesia, from Java, right next to Bali. So it's asper, which are these golden columns that you see, and then beton, which are the black splits, which have a higher level of flexibility embedded in them. So theoretically, wherever you work, if you would work with a community in Brazil, say, you'll go to guadua or a different type of species. But again, there's a local species that you can use to potentially adopt a design like this. The point of the pavilion, though, is say you're in Dubai and you want to make an eco-resort and you want to build with bamboo. The material is not available, the craftsmanship is not available, but you may have a local contractor who can assemble a complex IKEA kit. Then we can use global shipping routes to bring this design to them and give them an opportunity to work with this material as well.
Can you answer the engineering input?
The engineering input. Oh, we have embedded in our design tools a series of real-time structural performance assessment tools built in that absorb the parameters of the bamboo that we're working with. So the parametric model that we have, as we're designing it in real time, gives us structural feedback on how this behaves. So we've gone through a whole series of iterations to check how far we can tilt it, how far we can overhang it, to get to the final end result.
And do you ever find any difficulty between that kind of like intelligence of engineering design, meeting the crafts and actually testing, and are there any codes that you have to adhere to?
Bamboo architecture faces a huge challenge that there is no building code available for the most parts of the world, and a lot of engineering research needs to happen in order to bring it to that level. Right now it's pretty much where timber construction was maybe 150 years ago, and so we're missing these building codes. So in parallel to pushing the architectural design, we need to also push the building codes. The challenge there, we find, is that what we're trying to do to help there is to produce hooks that will increase demand, so that there's a greater pressure on global governments to push for that. Through INBAR, the International Bamboo and Rattan organization that I'm also part of, a lot of these efforts are taking place in parallel. But we need to push simultaneously from the bottom and pull from the top.
Thank you.
And did you find it easily to build with this technology of virtual vision, so it's make things easy, faster? How long does it take you to do it?
Yes, so the local workers on site in Bali, they usually work with physical scaled models because they cannot read any drawings. So that's a huge challenge of how you can actually communicate your design intent. For us also, being their language is a huge issue. They speak Bahasa, we speak English, so we cannot really communicate with words. But by giving them these augmented reality headsets, they immediately understand the design intent because it is directly in front of them. So every piece that we talk about, they see it in front of them. So they can take the bamboo pieces, they can bend it, they can assemble it. So it's a very immersive and intuitive way to assemble or construct architectural designs.
The prefabrication of it in Bali took roughly around 2 weeks, and the most time-consuming part was the glue laminated bamboo rings.
Laminated, yeah.
And then the assembly in Taiwan in 7 days. It was done for the first time with all the teething issues that the first-time assembly of this would have, and that we can now improve over time. So it should be very fast.
Yeah, it's great. Yeah, thank you.
You've gone to a lot of effort to also make an app where people can download and see how this is done. So have you thought about scalability, or is it still restricted to one object in one location sort of thing, or larger uses than just one use?
Thanks for your question. I actually forgot to mention that point. The scalability of this is very important. We purposefully developed a very complex design to prove that it is possible to develop with these tools. If it's possible for something as complex as this one, a much simpler, straightforward project like a house or a small shed, which may respond to emergent housing need or emergency response, is also possible with that. The app itself is purposefully designed for this project specifically, but we can very easily interchange the geometries and the notations in there to absorb different types of design. The app for this one is currently still available on the App Store. You can download it. We can put the pavilion on stage here if you want to, in AR, to explore it through the phone apps. But the fact that this infrastructure is available enables anybody, if they would want to use this technology for different types of architecture with different degrees of complexity. As a proof of concept, as a display project, by showing that something like this is possible, it opens up the register for all types of other projects to come in, of different scales, different sizes.
Thank you. Thank you very much.
Thank you.
Thank you.